Today's topic is household maximization. Household maximization. For getting to the household maximization, at first we have to understand what are the consumptions of different period. Now, consumption in different periods are, suppose consumption for the first period is C1, consumption for the second period is C2, and by this way we can say that consumption for the Tth period is Ct. So in this way we have written the consumption in the all the periods, that is C1, C2, and it goes up to Ct. Similarly, income in all the periods are y1, y2, y3, and it goes up to yt. Utility function or utility in all the periods are equal to u of c1, u of c2, and it goes up to u of ct. So that is the utility of all the periods, u of c1, u of c2, and it goes up to u of ct. Now what is our lifetime utility? Lifetime utility means that starts from one period but goes up to capital T period. So this is our lifetime utility. For getting that lifetime utility, we have to take the summation of u of ct, and it goes up to t2. It goes up to capital T, and it starts from 1. So this is our lifetime utility. Now, if we assume that the individual has the initial wealth of A0 and labor income of Y1, Y2, Y3 to YT in T period of his life. What am I saying here? Suppose the individual has some amount of initial wealth, that is A0, and in all the years of his life he has earned some amount of labor income. In the first year his labor income was y1, in the second year his labor income was y2, and in this way it goes up to yt. So that is the labor income of his life in the t period of his life. So now individual budget constant will look like. How individual budget constant will look like? As we know that individual budget constant will be equal to total consumption by the consumer and total wealth or total income that the consumer has. Now total consumption can be total consumption can be less than the total income, or total consumption can be equal to the now what have I trying to say? The total consumption is basically can be less than our total income, or the total consumption can be equal to the total income. So we have written total consumption less than equals to total income. What is total consumption? Total consumption is ct, and ct t is equal to 1 to capital T, summation t is equal to 1 to t. And what is total income? Total income is the initial wealth plus the labor income till the t period, where t is equal to 1 to t. So now we are going to take it as identity, that ct is equal to a0 plus yt. That means total income and total consumption are equal till the t period. Now we will try to optimize it. What is our constant function and what is our objective function? So basically this is our objective function, v is equal to summation t is equal to 1 to t uct, and this is our this is our constant function. This is our objective function, this is our constant function. So we will try to make a dynamic optimization of this. So we have written at first we have written the objective function, then we have written the constant, and we have multiplied the constant with lambda as we do in the optimization. At first we will try to derivative or differentiate the equation with respect to ct. So when we have differentiated this equation with respect to ct, we have obtained u dash ct, that is the derivative of this portion. That is basically the derivative of this portion is basically u dash ct. This portion is being we have done the derivative of this portion, and this is basically ct, u dash ct. After doing the derivative of this portion, we have obtained u dash ct, and after doing the derivative of this portion with respect to ct, all of this portion will not have any derivative, but this portion have a derivative, and ct and ct will be ct and ct will be gone, so we will get only lambda will survive. So and there is a minus in this portion, so we get minus lambda is equal to 0. So that is the derivative of the function or L with respect to Ct. So from this we can get that u dash Ct is equal to lambda. If we put lambda on the right hand side of the equation, then u dash Ct is equal to lambda. Similarly, if we do the derivative of this function with respect to lambda, then what will we get? Then we will get this entire term. This entire term will be obtained, and this is from this equation we can get the value of Ct, that will be equal to a0 plus summation yt. So this is very easy now. So number one is saying, this is saying that u dash Ct is what? U dash Ct is the marginal utility. And what is marginal utility? Marginal utility is equal to lambda. Now the question is, what is lambda? Lambda is a constant, so that means we can say from here that marginal utility is constant, because u dash Ct, that is marginal utility, is obtained as lambda. So we can say from here that marginal utility is constant. Okay. Similarly, what can we externally say? We can externally say that the marginal utility is constant for every period. So obviously, if the marginal utility is constant for every period, then the consumption for every period will also be equal, or will also be kind of same. So consumption in each period is equal, that is C1 is equal to C2, and it goes up to Ct. Now, if rate of interest is same, saving is same, and consumption is also same in each period, then what can we say? All of these are same, so we will try to manipulate this equation. Now, what is summation Ct? Summation Ct is the consumption of all the periods. So if we multiply the Ct with T, why am I multiplying Ct with T? Because consumption in all the periods are same, so we can easily multiply Ct with capital T. By that we can get the total consumption, as consumption is same in each of the periods. So T into Ct is equal to a0 plus summation yt, and by this T, by dividing the equation with respect to capital T, we can get the value of Ct. What will be Ct? Ct is equal to 1 by T into a0 plus summation yt. Now this is our individual income. Every individual has this amount of income, that is 1 by T into a0 plus summation yt. This is every individual's income, as well as consumption, because this amount the individual is consuming, so this is the consumption. This is the consumption of the individual, as well as this is the income of the individual. Now, if the individual divides total income of his life in each period equally, that means the individual is giving the income of his life to every period equally, then we can say that what is the optimality condition we have obtained from the earlier portion or earlier page. The optimality condition that we have obtained is the marginal utility is constant, that is u dash Ct is equal to lambda. So u dash Ct is equal to lambda. What is u dash Ct? U dash Ct is equal to marginal utility. So we have found it in the earlier portion that marginal utility is equal to lambda. So marginal utility is constant. That is the optimality condition that we have obtained. And what was the second optimality condition that we have obtained? That the consumption in each period, consumption in first period to second period to tth period are equal. Now, in terms of flow budget identity, we want to maximize it. Okay, what is the flow budget identity? Flow budget identity shows us that the current asset. What is the current asset? The current asset is denoted as AT. So flow budget identity shows that this current asset is equal to previous asset. Previous asset is shown as AT minus 1 plus current income plus minus current consumption. So what is my current income and current consumption? If I subtract my current income and current consumption, then this is and then if we add this with previous asset, that is AT minus 1, then that will be my current asset, and it is denoted as flow budget identity. Okay, so mathematically if I want to show this, so suppose my previous asset is 20 rupees. 1 minute. Suppose my previous asset is 20 rupees. My current income, that is YT, is equal to 30 rupees and my current consumption is 15 rupees. So what have I obtained? 20 plus 30 is equal to 50 minus 15 is equal to 35. So this 35 is equal to my current asset, or this is my 80. Now we have to manipulate this function, and we have to manipulate this equation and find out CT, and after obtaining the value of CT we have gotten the value of CT as 80 minus 1 minus 80 plus YT. So this is our constant function, and this is not a difficult thing to understand this. Now this U of CT, what was U of your CT? U of CT we have obtained it in the earlier slides, that U of CT is basically the value function. V is equal to U of CT summation T is equal to 1 to T. U of CT was our V value. So we will maximize this U of CT again now, but this time the constant function will be CT is equal to 80 minus 1 minus 80 plus YT. This is our constant function. In the earlier portion our constant function was different. Our constant function was this was our constant function in the earlier portion. This function is basically our constant function, okay. But now our constant function this is our constant function in the earlier portion, and this was our maximizing function. But now our constant function has changed. Our constant function has become, this is our constant function now. So this is our constant function, and this is our entire equation or entire Lagrange. But this is, in this time lambda is not constant. Here it is denoted as lambda t. That means it is not constant. Lambda will not be constant. So at first we will try to differentiate it with respect to CT. When we are differentiating it with respect to CT, what we have obtained? We have obtained U dash CT minus lambda t is equal to 0. This differentiation is not very difficult to understand. Then we have tried to differentiate it with respect to UT. After differentiating with respect to UT, we are obtaining lambda t plus 1 minus lambda t is equal to 0. Similarly, when we have differentiated it with respect to lambda t, we have obtained 80 minus 1 minus 80 plus YT minus CT is equal to 0. Now what are the generalizations that we have actually obtained from these equations? U dash CT is equal to lambda t. That means marginal utility of that period is equal to marginal utility of money in that period. That means what is lambda t? Lambda t is the marginal utility of money. So we are getting that marginal utility of consumption in that period is equal to marginal utility of money in that period, and U dash CT is equal to lambda. How is this happening? Because lambda t plus 1 and lambda t are equal, because marginal utility of all the periods are same. Marginal utility of money in all the periods are same. So we can say that lambda t and lambda t plus 1 and lambda all are equal. So we have just put in lambda in place of lambda t. So this is giving us U dash CT is equal to lambda. Now consumption in all the periods are same. Now we will try to consider the interest rate and consumption. In the previous segments or previous mathematical derivation, we have considered that there was no income in rate or no interest rate on consumption. So here we are going to assume that interest rate is present. Now what will happen if the interest rate is present? When the interest rate is present, then our utility function is, this is our utility function as it was in the earlier segment also. Now this is our individual budget constant. It is also same. There is no difference in this individual budget constant or this utility function. Now here R is constant. If our rate of interest is constant, then lifetime individual budget constant will be like this. So what is this? This is basically our total consumption, and this is our total income. So we have discounted our total income and total consumption. Discounted by how? Discounted by dividing it with respect to 1 plus r to the power t. Similarly, yt is also divided with 1 plus r to the power t. Now this portion is divided into 1 plus r to the power t. This is also divided into 1 plus r to the power t, but this a0, that is the asset income, it is not discounted with respect to 1 plus r to the power t, because it is the initial income. Initial asset income or anything that is initial is not required to be discounted. So if we take the relative risk aversion form of the utility function, now this is a different concept, but we have to just take the form of the relative risk aversion in this utility function. Then what is actually the relative risk aversion form of the utility function? We have taken it from outside, but this is a different topic or different concept. We have just taken the formula in this portion. Now what is relative risk aversion form? Relative risk aversion form is u of ct is equal to ct to the power 1 minus theta entire divided by 1 minus theta. Ct to the power 1 minus theta divided by 1 minus theta. What is theta? Theta is a risk aversion parameter, and theta is greater than 0. That means theta is positive, and theta is inverse of the elasticity of substitution. So this specification of theta is very much important. Okay. Now lifetime utility is now becoming, when our this is our lifetime utility. This risk aversion form is also our lifetime utility. What is the risk aversion form? This is the risk aversion form. This is also our lifetime utility. So we have to discount this risk aversion form. And what is the way of discounting it? Just divide it with 1 plus r to the power t. Here we have divided this lifetime utility by 1 plus rho to the power t. This is 1 plus rho to the power t. Why have we taken rho here? Because this discount rate is not a normal discount rate, it is a subjective discount rate. That's why we have divided it with rho. Now here marginal utility, for getting to the marginal utility we have to find u dash. Okay, so for getting to u dash we will differentiate it. We will differentiate it with respect to ct, and after differentiated it with respect to ct, we have obtained that 1 plus rho to the power t ct minus theta. This is the entire derivation, and it is very easy. This derivative is very easy to understand. Nextly, so marginal utility, what is marginal utility now? This is marginal utility for t period that we have obtained here. This is basically the marginal utility for t period, that is 1 by 1 plus rho to the power t ct minus theta, where t is equal to 1 to t. So this is our marginal utility of the t period. You can easily denote here that there is t period, all of this are in the t, all the terms are in the t term. So this is the marginal utility of the t period. So how will the marginal utility of t plus 1 period look like? So the marginal utility of t plus 1 period will look like 1 by 1 plus rho to the power t plus 1 ct plus 1 to the power minus theta. So this is the marginal utility of t plus 1 period, and where t is equal to 1 to capital T. So 1 by 1 plus rho to the power t plus 1 into c t plus 1 minus theta. This is our marginal period utility for the period t plus 1. Now in the case of optimization, we know that marginal utility of all the periods are supposed to be same in the case of optimization. So obviously marginal utility of t period and marginal utility of t plus 1 period are supposed to be same. So ct to the power minus theta and 1 divided by 1 plus rho to the power t, and ct minus ct plus 1 to the power minus theta divided by 1 plus rho to the power t plus 1. All these two are also supposed to be same. So when these two are supposed to be same, then we are just putting it into the equation, and we are trying to discount this part. This part is supposed to be discounted again by multiplying it with 1 plus r. We are discounting the, because it is not the initial or current stage of income, it is t plus 1. T plus 1 is basically the future period of income or future period of consumption. So future period of income or future period of consumption are supposed to be discounted. So this part is basically future period consumption. So future period consumption are supposed to be discounted. So this is discounted, and this is discounted by multiplying it with respect to 1 plus r. Now after deriving this, at first we will try to divide this and cross multiply this, and we will try to find out ct plus 1 divided by ct, and at the end we have founded out ct plus 1 by ct, and that is 1 plus r divided by 1 plus rho in to the power 1 by theta. This is a very easy derivation. You can watch the derivation. This is not a very difficult derivation. Anybody can understand this derivation. Now, at first, if we consider then rho and p are same. So in look at the earlier portion of the equation. This was the last part of the equation where we have obtained this equation. This is our equation. This was our equation that we have obtained in the last portion. This was our equation. Now, in this equation, we will try to put out the value of rho and interest rate, that is R. So, R and rho will be tried to put in the equation, and we will try to find out how Ct plus 1 and Ct are related by putting the values of rho and R. So, if rho and interest rate, that is R and P, R and not P, it is rho, R and rho. If R and rho are same, then what will happen? If R and rho are same, then we are going to get Ct plus 1 divided by Ct is equal to 1 by 1, because R and rho are same, so both will be cut. So we are getting Ct plus 1 divided by Ct, that is 1 by 1, and that is Ct plus 1 is equal to Ct. Because if we cross multiply it, then we will get Ct plus 1 divided by Ct. So consumption in T period and consumption in T plus 1 period are same. So consumption in all the periods are same. So this will give a very linear function, linear curve, horizontal to the x-axis. Next, if we go that R is greater than P, that means rate of interest is greater than rho. Sorry, not P, it is rho. Rate of interest is greater than rho. So in this type of cases, when rate of interest is greater than rho, then what will happen? Suppose rate of interest is greater than rho, then we will be considered towards your future. You will be much more attentive towards your future. You really want to consume more in the future period, and you want to consume less in the current period. You can easily find out this by solving the equation. Just put the value of R and rho in the equation, and suppose R is greater and rho is smaller. In this way, you can easily determine that consumption in the future period, or that is consumption in the T1 period, will be greater than consumption in the current period or consumption in the T period. So consumption is rising over time because future consumption is greater. When rate of interest is greater than rho, then the future consumption is greater, so consumption is rising over time. So the graphical representation will be a upward rising path. Similarly, if rate of interest is less than rho, that means rate of interest is less than rho, or the rate of interest is less than the subjective discount rate. What is rho? Rho is basically the subjective discount rate. So in this equation, we will get that the current consumption is greater, but the future consumption is lesser. That means future consumption will drop down with respect to the time, and current consumption is actually greater. So consumption is falling over time here, and the graphical representation is showing a downward rising path. Mankiw and Hall examines how much consumption growth takes place to variation of R. Mankiw and Hall were the economists who actually has determined that the consumption growth takes place due to the variation of rate of interest, and by how much the consumption changing or consumption growth takes place due to the variation of R.